Well, hello everyone, and welcome back to Adrian's Digital Basement 2. On today's video, we're going to be testing out some random ISA cards, and I think some of these are broken, so I'm going to try to do a little bit of repair work, a little bit of investigation work. Today's video is just going to be a casual fooling around video. For doing this testing, I'm going to be using my 386SX motherboard. I kind of like this. It's a sweet spot, so to speak. It's not too slow, so it's kind of capable, but it's fully just a normal ISA motherboard. It doesn't have any onboard peripherals, so if you're going to be using things like hard drive controllers, then you can test without having to try to disable all those onboard peripherals. I currently have it set up and actually booted because I like to test to make sure everything is working before I get started. This thing's got an IDE floppy controller with a compact flash card. It has a VGA card, and it has this little ROM card. Let me turn off the power and just show this. I've shown it on the channel a bunch of times, but this little card basically allows you to add option ROMs to any ISA-based system. So in here, I just have the XTIDE AT large BIOS, and it does let you address where in memory map it's actually located. You can have a second ROM if you so desire, and this is the Monotech ISA double ROM card. Now, you can buy these from Monotech. If you check out their website, just search for Monotech online, but they also had Gerbers available to make these PCBs. So I ended up making a bunch of these at some point in the past, back when making PCBs was cheap and easy for us in the US. With that in the computer, if we turn this on and switch over to my capture device, there it is. This machine has 8 megs of RAM. There's the IDE booting up. Let's just try to fix this. So it's, okay, well, it's cutting off a couple pixels off on the left side. What am I going to say about this machine? It's 40 megahertz. It has a crystal oscillator I can change out, but it's an AMD 40 megahertz 36SX. So like I said, it's pretty fast. I have this mounted on this little tray that allows me just to set it on my bench, and the cards plug in properly. The speaker's hot glued in place, so it all works. And yeah, I don't know what to say. This is a great little test bench. I really love this little thing. And of course, it had battery leakage at some point in the past, and I have since cleaned that up, and it was minimal damage. And then I put a little battery holder, and of course, well, I don't know if I have a diode in place, actually, because I don't really need one, because it looks like I have it plugged into the external battery connector. Anyhow, let's take a look at the cards that we're going to be taking a look at today. Incidentally, by the way, I have this riser card installed. Let's shut the power off. This is a little riser card, so I can run the cards this way so you can see them on the bench, like this. Well, maybe if I slide this up a little bit, there we go. Now you can see the card while it's under test. So our cards that we're going to be looking at today, we have this Crystal Audio sound card. Looks like it's from Media Magic, warranty void if removed. Part number PCB, oh, maybe that's irrelevant number, isn't it? I don't know what kind of card this is. Obviously, it's a Media Magic sound card, but it's a Crystal Audio sound card, which means it will be Sound Blaster compatible. And I don't remember if these Crystal Audio chips, this older one, has the enhanced FM or not. But either way, this cap is odd, how it's sort of lying down, but I suppose, I don't know, why would they have done that and not just used one of these? So maybe someone has swapped that out. Oh, this one too, kind of odd. Not sure what's going on with that. I totally get that these are lying down, although they're not glued down. So that's kind of odd as well. And there's a missing crystal there, but it doesn't look like anything has ever been in place of this. This sticker, or this note on the back, was not from me. Random ISA card number 3, can you fix it? That came from the person who gave this to me. Looks like a little bit of schmutz on the bottom, and there's an X and a question mark. Anyhow, should be able to see if this works using Unisound. That's a really good driver for DOS for these types of old cards, and we'll configure these. Notice there's no jumpers on here for the most part, and that's because these are pretty much auto configure, and that utility will configure these. So that's card number 1, and I might not do them in this exact order. This is a EGA card, a very, very generic one. So the chipset that's on here, yeah, PEGA, so Paradise EGA chipset. I don't think this card itself was made by them. They pretty much OEM'd their main ASIC here out to everyone. The original IBM EGA card was a big card with lots and lots of chips on it. So Paradise and other manufacturers condensed all that logic down to just be this one ASIC. These RCA jacks are not used by any kind of output when the card is like this. These aren't like for composite video, for instance, not on EGA cards. They're wired up directly to this expansion header, and supposedly you could plug stuff into this and then that would do stuff. I don't know, I never really figured out exactly what these were used for, but they're on all EGA cards. So if you see if you see a 9-pin and you see 2 RCA jacks, you can pretty much assume that it's an EGA card. I mean, it could be a CGA card where one is monochrome, one is color composite, but when it says PEGA, kind of gives it away. Generic ROM, because EGA cards and VGA cards need to have their own ROM BIOS. Otherwise, the ROM BIOS that's on the motherboard actually runs CGA and monochrome. It's built in, but it's not for EGA cards. What is there to say about this? What do we see on this sticker here? There's an FCC ID. It does say Paradise System, so I suppose this is a Paradise card. Made in Hong Kong. There's our FCC ID. Maybe I should look that up and we'll see if we can figure out exactly what this card is. Maybe it'll give us a more accurate model number. So I like to use Google Lens. It just sort of shortcuts this process of just typing that stuff in. It's an 8-bit ISA card. Well, we know that. It's EGA. We know that. Paradise Systems, assembly number. I mean, none of this is particularly great. Ultimately, what we're looking for is information on how to set up these switches, because that is kind of what we need. And the original IBM EGA card only had 4 switches, and this has, what does that look like, 6 or 5 switches? We can't see other listings for this card, and yep, they match this one. They definitely match this one. So this one says it's a PEGA 1A. I'm not sure any of these people actually know what this card is. Anyhow, we'll do more looking up about this card, maybe find an entry for it, say on the retro web, to be able to figure out the switches when we get to this card. Next up is this card. This says NCL America, and obviously we can tell that this is an IDE and a floppy controller card. This here is the floppy controller chip. It says the paddle chip, but FDC 37375, whatever, that obviously is a floppy controller. When it comes to IDE, you know, there's really not much to it, since of course IDE is just an extension of the ISA bus. So typically, say these bus drivers, most of these signals are just going to go down to these LS245s directly to this. There should be a little bit of select logic. Maybe it's over here that drives this, you know, for primary slave, that kind of thing. And then the IO address that the IDE card responds to, that has to be selected on the card. So probably this looks like a PAL chip. Yes, there we go, that's a PAL. That'll have the select logic for both the floppy controller and the IDE port. Now this does have a ROM chip, which I'm imagining is going to be for the IDE, probably to allow for additional or larger drives, auto detection of larger drives and things like that, sort of like an XT IDE. I don't know if this is any good. If it is, and if it's interesting, we're gonna dump this and I'll upload it somewhere for other people to look at. Most likely, a good use case for this would be just to put XT IDE BIOS on here. And that means just plugging this into any machine like this that, well, this machine has a really old BIOS, which is why I have to use my little XT IDE card. This might be a really good solution for me for testing on the bench, because I can just have one card that has the IDE BIOS and the IDE ports on it. What is odd is this actually has SRAM on here. I think this is 2K of SRAM. I don't think I've ever seen such a simplistic IDE/floppy controller with its own memory. That's kind of odd, but maybe this thing does some stuff, and instead of taking like 1K of conventional memory, which XT IDE does, this can just store its parameters right in that little SRAM. That's kind of cool. Disable BIOS. Unlabeled jumper 1, jumper 2, jumper 3, unlabeled. All these are unlabeled, which is stupid. There's so much room on here. Why wouldn't they just have printed what those did? They just labeled this one here, and they didn't label anything else. On the back, random ISA card number 1. I have no idea what this is. Well, I already mentioned that that is going to be an IDE floppy controller. I don't really see anything on the back of the card, a little bit of scratches up here, but this card looks in good shape otherwise. And by the way, these cards, the ones with these blue post-it notes, come from Jared. Jared sent me a bunch of Lisa parts that'll be coming up in an upcoming video. And well, I I show those cards in that video. So this will be out of sequence a little bit because this video will come out before the Lisa video where I open that box full of parts. So just FYI, thank you very much, Jared, for sending in those 2 cards. I think there might have been some other cards Jared sent in, but in my stack that I'm working on today, we just have those 2. And there is one more card we're going to be looking at, and it's this. It's another Paradise card, but this is actually a VGA card, and there it is. And it doesn't have any dip switches, even though it has the provisions for them. Now, I have an X on here because I think this card might be broken. So I want to poke around a little bit and see if we can figure out what might be wrong with this. Now, I actually have another one of these, and I thought it was identical, but it isn't exactly the same. It's this one, and this one does work. It does have switches on it. Is everything super similar? -08. I mean, maybe the ROM is a little bit different. So it's a Paradise VGA chip, but it's a Western Digital ROM. So I'm assuming this is an OEM Western Digital VGA card. Anyhow, this one works perfectly. I was thinking with this one, I didn't look at it. I just assumed, I'm like, oh, it's the same. Oh, it says Western Digital right here, by the way. I was like, oh, maybe the switches are set wrong. Well, clearly not, because there's no switches on this one. What's this little chip in the corner here? Ah, a PAL. That's interesting. So that's handling some of the logic simplification on this card. Anyhow, it'll be very interesting to see. Oh, it's weird. I just noticed there's a tick mark here and an X. So does this card work or does it not work? There's a tick mark there as well. Okay, we'll figure that out. That might be really boring and this one might work. So, because of that, let's just start with this card. So in here I have, I think, a Cirrus Logic VGA card, 16-bit one. It's nice and fast. I like this one. And I write fast on there. I don't know what the arrow is for, but yeah, fast card. Let's try this. This is the X'd out 8-bit card. Now these 8-bit cards are great. Well, I mean, they're not great. They're good because they work on stuff like XTs. Now, a lot of times these cards work on XTs as well. You just don't insert this and the card will auto detect that and just work. I usually write if the card is 8-bit compatible, but lately I've just been keeping one of these around. So if I'm using an XT and I want VGA just for easy hookup to an LCD or whatever, I just grab this card. These are really slow. Performance is terrible on these, especially this chip. It's just not great. And to be honest, it'd be an interesting experiment to see what performance difference we're going to have if this one in my left hand works in 8-bit mode versus this. This is a very fast card. We should try it. This thing has both 8-bit slots and 16-bit slots. Let's try both these cards, see about the performance difference. But first, let's see if this X card actually does work. All right, here we go. Let's turn this on. Oh, okay. Well, I don't know what the deal is with the X on there because it clearly works. Clearly it works. Let's do a quick speed test on here. We'll just run speed 600. Oops, there's no change directory there. It's just speed 600. And this will give us a very rudimentary speed test for at least 80 column, 24 line text mode. So 877 characters per millisecond, just along the bottom right there where I'm pointing. So I'm going to write that down on this back of this Post-it note. 877. Next, let's try my 16-bit card, but we'll try this in 16-bit slot, so best possible performance, at least on this particular motherboard. Now, this does allow overclocking of the ISA bus. I don't know if I've done that or not. I think not. It's probably just in the default configuration. So we'll just see what this is in the default mode. Speed 600. Okay. I mean, the difference is unbelievably substantial there. 5,067 versus 877. I mean, more than 5 times faster just to have double the bandwidth there. There's not any kind of clock speed improvement. It's just double the bandwidth. I'll move this over one slot into an 8-bit slot, like so. Let's see if this can work. Some cards don't work. Ah, this card does not work in an 8-bit slot. That was interesting. Well, I know I have some cards that do. Let me grab another card. All right, here's another card that I think works in 8-bit slots. An AccuMOS card. Now, there's a story behind AccuMOS. I don't remember what it is. I don't like to use this card particularly in a capture setup scenario like this because the output has some interference patterns on the capture setup. I mean, it's just minor, but I don't love it. First, we'll test the performance of this, which I think is going to be a lot slower than that other one, getting 50, 67 characters per millisecond. Right, here we go. Oh, this one's not as fast. So we're getting 3795. And this is what, unfortunately with ISA cards, there is a big variance from one to another. And a lot of times it has to do with wait states and stuff like that. And I'm pretty sure with this Acumos card, it has a jumper for wait states. Yes, look at this. PCAT 0 wait states. That is currently set. Let's turn this off and just see what that does performance-wise. I think it's going to be even slower. There's just, it's funny how one card to another, you'd think like the ISA bus speed's the same, everything is the same. And when you have a set to 0 wait state, which I'm pretty sure this has a 0 wait state jumper, it is on, so that's on. But yet, look at that performance difference, 5067 to 3795. And I mean, that's text mode, but I can tell you that performance difference is there in graphics modes as well. So if you're playing Doom or any game that's pushing pixels through to the card, that's a sizable difference. Okay, so this is with that jumper removed. Oops, I'm sorry, I wasn't paying attention, and you do need to boot the computer without EMM386 or maybe HiMem-Sys. I can't remember. I think it's EMM386 running. So that's why I hold down Shift when this machine boots up if I'm going to be running speed 600, plus it boots faster. All right, let's see here. Speed 600. It's going to be faster or going to be slower? It's going to be the same. It's going to be exactly the same. So does that tell us that that switch doesn't work? That's interesting. That might well be the case, actually, that switch is not hooked up. Right, so you can see that's how the jumper was configured, not installed. And on the back side, how funny, it's connected to one of these ISA pins, with those two pins right there. What exactly is that doing? Okay, I think that's just unrelated. Maybe that's like 5 volts or something, because it looks like it goes to that pin and goes to that via. And let's see. Actually, it's the left pin there, so that's the right pin. Yeah, I don't know. I just don't know. 0 wait states. It's clearly labeled, but it clearly doesn't do anything. What else is on here? Anything else that looks like a jumper configuration? Nope. Not really. Okay, well, maybe that's why the performance of this card isn't as good as the other one, because something's wrong with that jumper. I mean, the jumpers itself obviously is fine, but this probably makes its way into this VGA2 chipset. And I remember the datasheet's available for this. So it's probably something that I could poke around with or something. This card doesn't have any other issues. It does work. Just seems that it ignores that particular setting. All right, anyhow, we'll put that back on. Just, it's a placebo switch. Oops. Oh, put it on both pins. There we go. And let's try it in an 8-bit slot. And let's see what the performance decrease is, because there definitely will be a decrease. But our question is going to be, by how much? There it is. The card's working fine in an 8-bit slot. And hold down Shift. Do you think it'll be half the speed? I mean, it's reasonable to assume that from 3795, it should be half the speed. So what, like 1800 or something like that? Speed 600. 1300. All right. Well, 1382. So without a doubt, 3795 was slower than the other card at 0 wait state mode. My assumption is if we took the jumper off on the Cirrus Logic card, the fast one, that's this one right here, that it probably would slow down to a similar speed to this. But 1382, while slower, and it's worse than half the speed, although just barely, it's still not quite twice as fast as that other card, this one here, but a substantial increase. So if you're using a VGA card on your XT, you want to give it every possible chance of being able to push pixels quickly. And the 877 is kind of a slow Achilles heel situation if that's what you're using. In an XT, you want to give that thing, it's 4.77 megahertz, give it all the chance it can get to push pixels, because that's a substantial difference. In an XT, maybe we wouldn't see such a dramatic difference. This computer is a lot faster and the bus is faster and all those things, but it just shows that there is a performance difference even from one 8-bit card to another that is worth trying to use a better card. And I'm wondering now with this one, let's test this fast Cirrus Logic one by taking the jumper off. Maybe the 0 wait state doesn't work in 8-bit mode, but it will if I have that jumper removed. I guess first we'll test it in the same motherboard with the 0 wait state jumper removed so we can see performance there, because I'm curious if it definitely matches the other card where I don't think the wait state jumper works. It does exactly matches the other card. So the Cirrus Logic card, the fast card with that jumper turned off, is now $37.95, which is exactly what the other card is, exactly the same. I think the AccuMOS actually could be Cirrus Logic's, like the people who made Cirrus Logic might have made AccuMOS. There's an interesting story behind that chip, and I think I made a video about it. I don't quite remember. Let's see if this card works. No, okay, so this card just does not work on 8-bit slots, no matter how that jumper is set. But that's pretty curious, isn't it, that this jumper works very well, while this jumper doesn't work at all. You know what's interesting? Look at this. Don't these cards look extremely similar? I mean, they're not exactly the same, obviously. Like this one has capability of more RAM. And this one, you could see the surface mount positions under the chips there, the DIP ICs. But look at the actual large quad flat pack IC. It's got the same dots in the corners. 144 pins. How many does this one have? Oh, 168. Okay, different number of pins. This one's a 2D accelerator, so it actually does accelerate some of the GDI stuff. So if you're in Windows and you're running the correct jumper driver. Oh, look at this, by the way. 0 wait state BIOS, and it's a resistor, and 0 wait state DRAM maybe, or DRAM size. Interesting. So this is on the fast one. Oh, look, enable 0 wait state BIOS. Yeah, see this? These seem so similar. I mean, they're not exactly the same, but they seem so similar. Anyhow, this has acceleration for 2D stuff. I don't know if the AccuMOS one does, but I think it does. Although this has a 91 date code and that has a 93 date code. So I don't know the story behind this. I'm sure someone watching will be able to comment on what the story is. But I do know that there's an issue with this, with the 0 wait state. So maybe that'll be a future video. If anyone's interested in seeing me try to troubleshoot why this jumper's not working, please let me know, because I'll be curious. I'd like to get this working as fast as this. I like fast video cards in the ISA space, at least. And I would like to be able to test a fast video card in 8-bit mode to see if the 0 wait state works in 8-bit mode and what kind of speed you're going to get out of that. Anyhow, back to our problematic card. This obviously works, so I gotta erase that X there. I must have tested it in a motherboard that was flaky or something. I don't know what else could explain that. So I usually draw the X with a Sharpie because it does come off, for the most part at least. Yeah, so that comes off. It was a black marker. I'll take off these tick marks that are there too. Yeah, this card works, good. Well, it's slow, but they're trusty, I guess. Like, I know these generally work, although look, I put an X on it because I didn't think it worked. But I mean, there's already a tick mark here, but just for extra tick markage, I'll put a tick mark there. All right, there's our first card down, experimentation complete. We're gonna go back to this card, the fast one, and make sure the wait state jumper is on. Yes, it is, because we want to give maximum performance to our testing of these other cards. Okay, so let's just double check this is working. I just want to hear the clicking. Yes, there we go. All right, let's test out this card next. And to do that, I'm just going to pop out this. And we'll pop out my little ROM card. And, you know, I guess I could be testing here in this thing, so let's do that. Just so you can see what goes on. And we have some glare, so I'll put this Bluesky underneath there. All right, let's see what happens. Obviously, I don't have the compact flash connected to that, but I'd like to see if the system posts and what the BIOS situation is all about. Now, there is a jumper here for disable BIOS, and it's set, so it might not even show BIOS. Oh, it does. Whoa, whoa. Okay, that was so fast. Let's do that again. I'm going to hit the pause button. Array adapter BIOS, ECS NCL 1990-1992 JFZ testing controller 0. And then it just immediately does that. Now that's normal for this particular computer. It's looking for ROM basic, which of course doesn't exist. And you know, ROM, what would happen if you put ROM on something like this card? Would that work? Or ROM, if you put basic on this card. Basic normally exists at like F000 or whatever, and on these types of motherboards, the regular BIOS takes up that space. So there's no room for basic to run in its normal place. But could you put basic somewhere else and this would actually work? Does anyone actually know if that's the case? I'd be very curious to find out, because that'd be kind of fun actually to put the cassette basic from IBM's machines on these much more modern computers. I'd be kind of curious to see if that worked. I think to test this further, I'm going to have to grab a compact flash adapter. Okay, here's a compact flash adapter. Let's get the card moved over. Now this is a 4 gig card. It totally may not support that. Let me grab a floppy drive to plug into this. 3.5 inch floppy drive. And my super long cable. There's no 1 marked on this board, pin 1 that is. It says J3 and I think J4, so I'm going to assume where it says that is pin 1. And we got to plug power into my floppy drive. Over here is a power connector. What I like about this floppy drive is it doesn't have anything on the bottom to impact when the motor is spinning, so you can just like leave it laying off to the side. Incidentally, this card that I normally use on my 16-bit stuff, this card I took the pin header off for IDE, put a right angle one on, that way this compact flash adapter could plug in and not stick off to the side. And then this is power for the compact flash adapter. I think I had a different bodge wire, but it kept breaking, so I put something a little bit more sturdy on there, and it's kind of janky, to be honest, that I used one with a pin, but whatever, it's been on there for a while and it works. I also swapped some of the LEDs around to the other side, so when I plug the card in this way, I can see the power LED. I like that as a reminder, hey, the system is on. I wired directly up to the hard drive LED header, LEDs, one for this, but the other one actually is this bodge wire here, and that tells me when the floppy drive is accessing, which is kind of nice. I don't need to use a 4-pin connector because that's what's on all of these. This has it right there, but it's not like I'm plugging a real hard drive thing into this ever. This is just for testing purposes. Therefore, I kind of love this. So I think green LED is for floppy and the pink one comes on when the hard drive is accessing, that one. So if I'm going to use this one in the future by swapping this ROM out with the XT IDE ROM, then I will do the same thing with the right angle. The only problem is this card's bigger, so this will stick up a lot more. Right now, this wouldn't actually fit in a normal case because obviously usually the case is like here. When you're talking about like the slot bracket, there's usually like maybe that much space. And I think the compact flash card sticks up maybe in too much. Anyways, it's not like I would ever use that inside a computer. Like I said, that's for testing purposes only. And if that were this case of this one, if I was using this, then who cares? All right, let's turn this on. Make sure everything is plugged in properly. First thing I need to see if the LED comes on with this. Nope, that's good. That means I didn't have the floppy cable on backwards. So that's excellent. Okay. Well, right off the bat, it did not detect my compact flash card because it didn't try to boot off of it. So let's set a drive here. Okay. And let's watch what this does. Nothing. I mean, I heard the floppy drive click. Let me grab a disk. Here's a copy of IBM DOS 3.3 on a 720K disk. This should work. Yes, that is loading. All right, cool. So the question is, what kind of a BIOS is on this card that it can't detect anything? What I probably need to do is copy Jim Leonard's utility that dumps the ROM, although I should just dump it externally. Also, the fact there's SRAM on here, that's just odd. That's just very odd. Do we have debug available to us here on this boot disk? Yes, we do. All right, let's see where this ROM might exist. It's not there. It's usually going to be floating around. There it is. John/Mark. I guess this was done by John and Mark. 1991. It is my assumption. How big is this ROM? It's a 27C128. So that means it's, what, 16 kilobytes in size. So somewhere in here is going to be some SRAM, I presume. And I wonder if I can find it. Oh, look, we can see some of the words there. Testing controller, which is what we saw. Channel 0, disk 0. Channel 0, disk 1. Channel 1, disk 0. It actually supports 4 hard drives. I don't think the controller chip, by the way, is for the floppy. On XT or 8-bit floppy controllers, that's often the case. But this is a 16-bit card. That means it's going to be used in a 286 or newer, and that already supports high-density disks and stuff like that. That would be the only reason why you'd have a BIOS on a floppy controller, would be for XTs that don't support anything over double-density disks. Drive type initialization ready. Just reading like the stuff that we see there. The NCL array host adapter board allows installation of up to 4 drives on 286 or 3 compatible computers. The main benefits are realized by using the array adapter under network applications where the user may mirror the drives. Mirror? Mirroring allows RAID 1? What? RAID 1 on a 286? I don't know if I've ever seen this. If the device will fail, the server will always function until repair. So this is talking about the drive 1 fails. Obviously, you can use either one. The feature supports 4 drives under DOS 5 without any loadable drivers. This installation program will set the CMOS RAM properly, allowing the resident ROM BIOS to link with the necessary support. I wonder, everyone, some of these old BIOSes, like on XTs, you had to execute some code. That didn't work. And I'm wondering if this is like that. The problem is like you don't know the entry address. I think if I dump this ROM, people will be able to reverse engineer it, and then we could figure out what the entry address is, because my assumption is it doesn't say like push a key for more, you know, like to go into a menu or something like that. But it does appear that this has more to it than the little splash screen that we saw there. So C800, I don't know, I'm just like guessing at like where it might run from. No, that's obviously not it either. Can we figure out where this runs from? I don't know, actually. I don't know enough about x86 assembly to just look at it and be able to tell where it goes. Now, the DOS 3.3 debug program, it doesn't have a disassembler in it. I don't think it does, at least. Let me just peer at this a little bit more. So C800, let's see here. So that's probably what's gonna just start. I'm just looking for a gap in the ROM here. And by gaps, I mean a bunch of Fs or something, just to kind of denote a block, a change in the block or something. Now we have all these strings, and now it just sort of went right into kind of describing how the program works. I'm just reading through this adapter, and it's recommended for users to do so. The following are adapter. Oh, look, entry address. So, okay. All right, so it's talking about the different memory addresses. So obviously there are some jumpers on here to configure that. So we're at the C800 right now, but it supports CA, D8, and DC. Hex, CMOS locations, 12, 19, 1A. I don't know what that means exactly. The INTR locations, channel 0, 14. I think that's the, oh, that's the interrupt. So it either supports 14 or 15, channel 1. I mean, this only has one IDE port, so why would it have 2 different interrupts? Power required. It's like the manual's in here. Oh, there it is right there. Manual installation. G equals C805. Didn't I just run that and it did not work? Select enter to install, escape to bypass. I swear we just did that. Maybe my syntax was wrong. Let's try again. Oh, look, there it is. How cool is that? That worked. All right, so this is all the text that we already saw. Too bad. Select enter for install. Okay, well, I don't want to erase my compact flash card, clearly. So I'm going to need to put a different one in. I luckily have a whole bunch of them. Like here's a 64 megabyte card, so we'll just stick this one in and we can format this card. And that way I'll just install IBM DOS 3.3. It can support up to 32 megabytes, I think is the limit. Although it's IBM version, I'm not totally sure on that. I can't believe the code itself had the entry location. That's funny. So debug. Maybe I was doing G. What was I doing? I didn't have the equal sign, I think, when I tried it, the entry point. Yeah, there it is. Okay. Oh. Auto configure. Okay. Oh, nice. All right, let's try auto configure. Channel 0, disk 1. Well, not installed. Oh, it just rebooted. Oh, did that say it detected it? Wait, hard drive type 1? Wait, what? It actually changed the BIOS. Well, I don't know what's going on here. F-disk. Let's see. We're going to see if we can format this little card. Hey, it's detecting it. I don't know what's on here. Oh, yeah, there's some stuff on here. So let's delete. Yeah, let's delete all of this stuff. D. Are you sure? Yes. This is because the drive's too big for this version of DOS. Delete the DOS partition. Extended. Oh, yes. Okay, there we go. Delete the DOS. I'm just deleting this stuff because I created this on something else and I don't think it was working. So now we're going to create a new partition. How big? Okay, I don't know how big that made it. 32 megs, I think, is the limit. So yeah, channel 0 ready, it said. So it somehow is using the CMOS memory to store the settings, because this is just SRAM. This is not non-volatile RAM. Let's look at how big the partition it just made is. It should be 32 megabytes, hopefully, or it's not going to work correctly. Yes. Yeah, total disk is 977 cylinders, and it's only used 512, so cool. So format C/S. Let's see if this works. This is a weird card, but I'm pretty excited to know that I can just stick a XT IDE image on there and it should work. Okay. Let's see if this actually can boot once it's done. I did a /S, so it should copy the system onto it. All right, there it is, 32 megabytes formatted. Let's Control-Delete, take the disk out, see if this boots. Okay, it doesn't. But I don't blame this card. And the reason why I say that is because I was trying to use this exact version of DOS to format this SD card or compact flash card using XT IDE, and it was doing exactly the same thing. It was not booting, it would just freeze right here after seeming like everything was working. So I think that this DOS version is bad. And by bad, I don't mean like there's something wrong with it, but maybe it just doesn't work with, I don't know, this kind of card or something like that. And it totally hard locks the computer. So I've put in a DOS 622 disk. Hopefully it's a disk that actually has F-disk and format on there, and it will just do this process again. Okay, so I have some weird stuff on here. It's trying to clear high memory. That's not going to work. That must have been for like an XT or something I was doing. Whoops. Oh, in case anyone's curious what type 1 is, it's a 10 meg hard drive. So not at all what the compact flash card is, but DOS was seeing the card properly. So that tells us that it must just rely on any hard drive being set in the BIOS, and then it will just hook and take over those routines. I'm holding down Shift to try to stop it from, nope, okay, that's gonna run. This says DOS 622 boot 720K. Well, that doesn't work. Okay, I try a different one. It's another DOS 622 disk. Boy, my disks are in bad shape. Like they're all randomized and full of junk. Okay, this looks like DOS 622 because it says starting MS-DOS. That other one must have been a different version, and I didn't relabel it. Hopefully we have F-disk and stuff. There is, oh good, the XT IDE stuff's on here as well. Cool. So is F-disk on here? Yes, this is a good disk. Let's recreate this partition, because maybe this partition is somehow bad or something. Delete non-DOS partition? Yeah, there's no non-DOS partition. Primary deletion. Enter volume label. There's no label. Are you sure? Good. Okay, so we're going to create a new one. Primary DOS. I don't want to make it max size. Let's just make it, again, 30 megabytes, so it would work with older versions of DOS. We got to set active partition. There we go. So now it's happy. Oh, wait. Oh, shoot, I just deleted it. No, I didn't. There we go. I pushed the wrong button. Okay, let's reboot. Let's format this drive. And my assumption is it will work. And then what I'm going to do is I'm going to set up XT IDE BIOS, and we're going to put that onto this card just to see if this is a worthwhile upgrade. So if you have one of these cards, you can make it a whole lot better than it actually is with this weird BIOS that's on here that we figured out how to use, at least. G equals C800:5, at least with the default configuration. And we'll let this format, and then, yes, this card might be better. This might be my normal go-to card for this stuff. Well, that'll be great. And just funny about the whole SRAM thing, though. You know, we should be able to see that SRAM on there. I'm going to copy everything from this onto the C drive. I don't know why. We're not going to overwrite command.com since that's already in the correct spot. I'm looking at the date codes on this card. This says 91. Do I see other date codes? I think that's it. Most of these have like weird date codes I can't decode. Oh, 92. So it's from 1992. All right, let's see if this boots. So, you know, it's not super old. There we go. So we are booting off the compact flash card. Cool. All right, well, we have IDE ATL, the large BIOS, and that should fit in this chip, right? Because it's a 16K EEPROM, 27128. It's kind of an odd one. I have a lot of 64s and a lot of 256s, but yeah, there we go. Anyways, so we need to run the XT IDE config utility. Okay, and we're going to load from file. And we're going to pick ATL. And the reason why I'm picking ATL, not the XT one, is I'm never going to use this in an XT with a 16-bit slot, right? So we'll load that one. We can't flash this file, but you can configure it nonetheless, and then we can save it back to disk, and then I can flash this, put this floppy disk, copy it onto a floppy disk, or move this as compact flash card to my main computer, and then I can flash that onto a real chip. So first off, device type, 16-bit. That's what this card is. The base command is normal. That's what this is, the default for the primary controller. Interrupt or polling mode. I mean, we should have interrupt mode. I don't know why polling, that's kind of slow. Whatever I was using that with was not going to result in good speed. And then our two drives that we have configured, we want to do auto. Hard drive internal write cache settings. I don't know, we should probably turn that off. So just block transfer, yes. CHS translation should be on auto. And for both of these should be the same. Yes, it is. And I think that's really it. Now, IDE controllers is set for 2, we should set it for 1. Otherwise, it's going to sit there and scan for another controller, which I'm never going to use anyways. It does need to steal some memory. We don't need to worry about power management. And what's here is boot settings. Display mode, I would just leave it as default. Number of floppy drives, again, auto detect. Scan for serial drives, no, because we don't really ever care about that. Selection timeout, if you want to speed this up. 540 times 54 milliseconds, so what is that? 1 second or 10 seconds. Either way, let's slow this, let's speed it up a little bit. I'm going to make it 250. In fact, I'm going to make it even faster because I don't need to wait. And display mode. Yeah, this is a really old version of the BIOS. Look at this, 2013. Oh well, there are much newer builds that have like more options than this, but this is good enough for testing. So we'll go with this. So we can't flash this anywhere. So we have to save it back to the original file. And it's updated the file on the compact flash card. And we're going to exit. Now what I need to do is shut the power off. And we're going to get the file that I put on this, put this in my card reader. And I need to take this off because we are going to dump this. Because I will be super curious to see if this thing really does behave and work properly with the normal XT IDE BIOS loaded onto this. Got to grab my EEPROM. device. Here it is, the T48. Put this in already. Okay, so right away, this is what's on the compact flash card. So ATL is the one I just configured. See, it has 2024 date code. All right, so we'll just pick a random AM27C128. Doesn't matter for reading. Reading is all the same on all of these. You just have to turn off the check ID. There's our John/Mark. And there's all the instructions, and there's a whole bunch of nothing in here. So that's actually telling us, let's see where this ends. There's the end. There should be, there's a 5F. Is that the checksum? What size is that? That is at 17FF. That's basically right at the 6K boundary. Weird. So I don't really know if this will map the large PROM in here correctly, and even the small one is 8K. So this is really small. This may not work. This chip might just be much bigger than this card will actually map into the address space on this computer. This is always the kind of guessing when you're working with cards like this, because we don't really know how this is decoding. It's all based on the PAL chip that's on this card as to how this is decoding. Either way, let's save this. All right, so I'm going to save this as NCL 16-bit ISA FT HDD adapter BIOS 227C128 7.5. So that's going to go there, saved. Excellent. Okay, so all I have handy on my desk here is a 256 chip, but it should work fine. First, I need to blank check it. The chip itself is an AMD chip, so I have the right one selected. It's always good to select the correct chip when you're programming the file, that is, or programming files onto these chips, just because the voltages and stuff are different from one to another. And in fact, the problem with this program is very inaccurate when it comes to what voltages and stuff these chips use. So sometimes I look up the data sheet and then I'll write on the chip with a marker, with a Sharpie, a fine Sharpie, what the actual voltages are, and then I'll set them appropriately. Okay, so there's the XT IDE Universal BIOS loaded, the one we configured, and it is potentially too big, because remember the other one stopped all the way at like 17FF or something like that, but this one, as you can see, this goes to 24A0, and then there's going to be some space with all these zeros, and there is the top, and that's the checksum byte at 2FFF. So much bigger than the other one. So this totally may not work. But if this is the case, what we'll do is we'll try one of the 8K ones, and maybe the 8K one is mapped in properly. Now the problem is this chip is double the size, and it actually goes to 8,000, so 7FFF. So I'm going to load this twice because I want it to be replicated in the chip. I just don't know how this chip is going to map into this socket, and it's quite possible that one of the address lines is held at like 5 volts or ground. And because of that, that means that we could be looking at the top half or the bottom half of this chip compared to this 128 chip that was in there, potentially. So what you do is we have to turn off this clear option, and we're going to load this at 4,000. It's going to load it twice into this chip. So if we go to 4,000, well, if we go to the top of the chip, there it is, Universal BIOS, and we go to 4,000, which is the halfway point, 4,000 hex, there it is again. Now, if it was the 8K BIOS, we could also load it again at 2,000 hex, but we can't because, yep, this BIOS is too large. It takes a little bit of the space there. Anyways, there we go. Let's program this and try this. This is maybe going to work, maybe not. We will find out briefly. And if this doesn't work, I'll grab another one of these chips here. I have another 27128, I think, floating around here, or 27256. That worked. I'm just going to program it again. I like to program these chips like a few times on this programmer. It's just not the best programmer in the world. And sometimes, I don't know, it doesn't make the cells strong enough. I don't know the right way to describe it, but I find that programming it multiple times will often make it work more reliably, especially in certain motherboards. It just is flaky, and you do it a few times like this, and then it's happier. Okay, there we go. 3 times the program. Now I need to place this back on here. There's a notch indicator right there, plus everything else faces that way, the notch. So let's get this in here and see if this works. Maybe it will, maybe it won't. If it does, it's going to be way cooler than the original BIOS, that's for sure. That's the difference in a certain amount of time, years gone by. Let's see, XT IDE, come on, maybe? Okay, what's happening now? It's trying to detect the hard drive, and I have the card removed. So we got to take the hard drive out. XT IDE does not rely on anything being set here. So it's better just to set to nothing. I just want to see if XTIDE comes up. It does. Nice. Oh, that's so sweet. Cool. I mean, that's great news. That makes this card so much cooler. So if I put the card back in, the one that we just formatted, and I will try my 4 gig card in a second because I have more utilities and stuff on there, obviously. There it is. It's going to boot. Yes. Oh, funny. There's a config sys on there. That's interesting. This is just the stuff I copied off the floppy disk. Well, I'll be, everyone. I'll be. This card totally works with ATL. And let's swap over to this bigger one here because I have some better tools and we can kind of poke around and maybe try to find that static RAM, that 2K of SRAM, which I'm pretty sure should be mapped up into the memory space somewhere. I am stoked by this actually working. Really stoked. So this is booted off my big card. And first let's try check it. Let's see what this actually sees. So we go to memory map. So there's our adapter ROM. Okay, so it sees it as 16 kilobytes. I'm not sure that that is actually accurate. This isn't the most accurate thing in the world. That's the BIOS. We can ignore that. It says high RAM. That's just incorrect. Let's go poke around a little bit at C800. You know, it's too bad. Yes, yes, okay, 16K. So that would be the whole 27128 if that's even accurate. Oh, you know what? Check-in might actually do a decent job at figuring that out. And the reason why is if we look at C800, you know, this, oops, that's the wrong way to do it. You got to put a :0 for the segment. There's XTIDE. So this is all the BIOS stuff, right? And we know that, what were we seeing? It was going to like CA00, let's see, oops. CA00, oh, not 800. Is this still XTIDE? Yes, I think it is. I just gotta do, oh yeah, there's the end right there. So I think that's how Check It can tell if this is 16K or not. No, it can't tell. I think if this chip were not in the socket, we wouldn't have all these zeros here. Oh, there we go. So it ended. There's that B7. It still might be able to tell, and here's why. If we look at CC00, oh, that's just all Fs. So it can't really tell the difference. CA00, so there's the B7. So that's the very top of the address space. No, I just did a little math in the calculator. 2FFF, which is the top of this ROM here, is actually 12K. Not 16K. So I'm not sure how it can, or why it's thinking that, yeah, I'm not sure why it's thinking that there's actually 16K of something loaded in there. So how do I do this? So C800, okay, so wait, 2E00. Okay, so if we keep deep dumping, we should see that top of this. There it is, there's B7, so that's the top. So 2FFF. I put 2 copies of the ROM in there. So if it is reading this chip properly, then what happens is if we do C800 and we do 4000, no, see, this is all Fs. So that would be the next copy of the ROM right there. We'd be seeing the next copy, that second copy, but it's definitely not. It's too bad I didn't fill the rest of the EEPROM with all zeros because we would have been able to see the top of the address space that it's actually mapped into. It's quite possible that that entire 16K is working. I just don't know how Check It can tell the difference between all these Fs here, which aren't really mapped into anything, and, well, the part that was mapped into the actual EEPROM. But yeah, this is just nothing. So if you get to C800 FFFF, that's 64 kilobytes starting from C800. The Intel stuff is all kind of weird with like the colon and how complicated it is. Either way, this doesn't really tell me where this SRAM exists. It's got to be mapped in there somewhere, but I don't know where. And it's only 2K, so it's not like it's super usable. It's like if it was 16K, you could maybe use it to put some stuff into high memory or whatever. Although on a 286 and up, it doesn't really matter anyways. It would be better for XTs. So I think there's no point really looking into any more of that. What we have is a card that was boring and now has a built-in XT IDE on it, and it totally freaking works. How awesome is that? Let's look at the speed of this card. I think I have under check it maybe, HD speed. Here we go. How is the performance? We'll go back to my other card just to see if there's any difference. 1038 kilobytes per second. That's what we're getting on this with this XT IDE BIOS. So we'll swap over to the other card. Look at all these, it's like a spaghetti wire situation here. We'll put this back into the same exact slot we were using, the same card. And I got to find my card, my compact flash card. This goes into here like so. And where's my Bluesky? That's my little proper upper. We'll turn this on. I don't remember if I had the floppy drive still enabled, so we got to turn that off if it is. Yes, okay, we got to get rid of that because it's not plugged in right now. I forgot to write down what the speed was, but it was what, 1038K, something like that. Oh, it doesn't work because without this installed, there's no auto detection of the hard drive. So pop that in, make sure you put it in correctly because of course this little card can be put in backwards and that would kill it. There are arrows silkscreen onto the back, which is excellent. There it is, InnoDisk 4 gigabytes. Yeah, that's a 2025 BIOS, much newer. So, oh, you know one thing you can do as well on a 386 is you can shadow the BIOS, which copies like the D800 on this card or C800 on this card into the system RAM. It'll run a whole lot faster. So like the hard drive routines. Oh, that seems a lot faster. Oh, no, it's not. 1011, I think it was like 1030 or something. So it was essentially a rounding error difference. Let's see if we can do a shadow on the XT IDE BIOS. This motherboard has some funniness when it comes to shadowing though, so it may not work. So see, there's the adapter shadow. We'll try turning that on. Shadow RAM option. Yeah, there's some problems with this motherboard. It doesn't, even though the settings are there in the BIOS, doesn't really work correctly. And it's something to do with the chipset. I said no adapter ROM caching. That's what I wrote on a sticker on the board right here. If this makes no difference, oops, if this doesn't speed up anything at all, then it's not working. Oh, it's definitely sped up. Oh yeah, look at that. 2,383. So that was just running the XT IDE BIOS in the system memory. It's in the upper memory. It's shadowed up there. It's not taking any of your conventional memory. That's how much faster that is. Let's see if we can do the same thing with that other card, and we should get that, what was it? I already forgot what it was. Boy, my memory is fast. It's because I'm talking, that's why. So there it is, C800. Let's try that. Go back to the other card. Oops. I like having the built-in BIOS there where I don't have to do anything. Like I don't need to worry about that little extra card because I'd like to use that extra card for other stuff, like maybe my RAM testing BIOS, for instance. It'd be cool to put that on there. And that way, I used to have it on there actually. It was both it was on there, and XT IDE and the other one were on there. It was like combined into one chip. Is everything good? I need to make sure. Yes, everything is good. Okay, we're set. Here we go, power up. Let's see if we get the performance improvement. It's working. Freaking awesome. Super awesome. Utils, check it. HD, oops. Check it, if I could type properly. Speed, here we go. No. Well, this is not any faster. Let's double check that I actually set the setting. Oops. I did, but it doesn't work. I almost feel like this is a BIOS problem. One way we can test this to see if it's not the card or it's not a problem with this card being slow is I changed it to the D800, right? That was the other space. And we're going to try this disable jumper that's on here for the BIOS. And, oh, I have both cards in there right now. Okay, well, anyways, there's the D800 one working. I forgot to take this one out. I assumed this was the one that was running. I didn't even try this one. And that was our problem. I assume. What's going on here? Boy, comedy of errors here, isn't it? Let's do this one more time. Oh, maybe the disable jumper doesn't work? Okay, D800. That's definitely this small card. Okay, there we go. I don't know why I didn't boot that one time, but it didn't. That was probably my fault somehow. Yeah, there it goes, nice and fast. 2300, I think it was. Yep, cool. Okay, so question is, let's take this card out. Let's see if that jumper works as advertised. When the jumper 11 is on, that was how it was, and the BIOS was working. So I'm going to change this back to C800, which is where that BIOS exists. Let's see if this BIOS is not detected right now. Good, it's not. So let's put the jumper in place. And reset the computer again. There's a bunch of other jumpers on here. I assume some of these change like the IRQ that's being used. Some of them probably change. Okay, there we go, cool. Let's hold down Shift. It's doing that thing again. Weird. I was going to say some of these probably change the location of the ROM. We saw that in the little instructions that were included with the original ROM, it did have the capability of being, oh really? Oh really? Missing operating system. That's highly unlikely, in my opinion. It may well be that I need to start using the much newer version of the ROM. Interesting. I wonder. Okay, well, that's weird, everyone. Is it the shadowing that's causing this problem? Let's turn this off. I mean, the ROM shouldn't know it's being shadowed or not, but this worked. Oops, keep banging it around. Missing operating system. No, you didn't corrupt my disk, did you? You dirty jerk. You jerk. Let's disable the BIOS by taking the jumper off. Switch back to that card. See if it corrupted my SD card. I'd be very annoyed if it did. Oh, you gotta be kidding me. Oh, no, it's working. So something is just weird with this BIOS. This version here, R631 from 2025, works perfectly with this card. This is weird, everyone. This is very weird. Okay, I'm just looking. I can't put this chip in here because this chip is a EEPROM. I'm going to need to make a new chip for this and I guess not use this old version of the BIOS. So that means I need to erase this one because I don't know. Oh, wait, maybe not. Let's see, what do I have here? I have a bunch of EEPROMs sitting here. That's a TI chip. I have some National Semiconductor ones that I can't program very well. Oh, here we go. Oh, no, that's a 512. Very annoying. Okay, I'm going to have to erase this chip. I know I have more. I just don't have them. I don't have them handy. If anything, I should just erase this chip. I'm going to erase both. How about that? I did save this already, so it's not like we don't have a copy of this particular original ROM that's on here. The preservation is complete, but I'm going to reuse this EEPROM because why not? So I peeled that sticker off. I'm going to have a small eraser here. So I'll just pop both of these chips in here. Can do 4 chips at a time. Just close the lid. The light's on, so that's perfect. While we wait, let's go back to my original card. So I'm taking this one out. And we're switching back to this one because I want to test this sound card. That was the last card we have to test, right? Where is it? Oh, and the EGA card. 2 cards to test. So while we're here, I'm going to turn on this shadowing because that seemed to work and that made the other card much faster. So we'll let that do its thing. I'm glad my card didn't get corrupted. I would have been extremely annoyed. Oh, hello, what are you doing? It didn't even show XT IDE, there it is. You know, this motherboard has a weird thing where like if it's in this last slot, it doesn't always work very reliably, but we're up and running. Let's just make sure we got full speed, check it. Oh, that's not what I meant to run. I wanted to run HD speed, which just happens to be in the same check it directory. I don't think it's related. This is made by Core International from 1986. Can't even figure out the size of the hard drive. It's negative 277 megabytes. But anyways, 2300K per second, nice and speedy. So let's plop in this Crystal audio card. Let's just see what happens. When it comes to rework on the back, by the way, there's none that's obvious. So those caps that were lying down. Oh wait, this is weird. Someone circled this. Is that this cap? Or is it that cap? I think it's the electrolytic. It's this one. Well, that's an electrolytic as well. Tantalum electrolytic. Apparently, I didn't realize back in the day, but these are, even though they're solid, they are still considered electrolytic. Someone changed that cap? Or circled it? Why? Odd. Anyways, these that are lying down don't look like they've been reworked. I don't see any rework that's obvious on here. Not even there. Oh no, that's reworked. Yeah, there's a bit of flux on there. Well, this card may be not working and we might need to do more diagnosis, but I'm just going to spread those legs apart. Don't want them to touch. There we go. Does everything else look okay? Oh, there's this one as well. Seems dumb to put the caps like this with the legs like that. That seems pretty bad, doesn't it? See how there's no solder that's flowed up around that leg? But on the back, it looks okay. Oh, someone has reworked that too. That's what the question mark's for, I guess. It's a resistor pack. Very odd. That would have been what was originally on here, but maybe got damaged. IDE disables, enables that stuff. I don't think this is necessary except for these ports. I doubt this stuff even does anything if you're not using those. In other words, see these two bus transceivers? That's going to connect these to the bus. And yeah, anyways. All right. I think this is good enough or safe enough to plug in. We'll just plug it in to this here so you can see it. If anything blows up or catches on fire or whatever. Bluesky propping upper device. There we go. Okay, here we go. 3, 2, 1. No smoke. Okay, system is posting. There we go. Uh-oh. Glitcherama. Hard drive's booting. Well, that's a funny situation. Let's pull that out. I just want to see if the glitching has subsided. Yes, no glitch. Let's pop it back in. If the glitching comes back. Yes, it's back. I can't believe the computer's booting though. With all that going on. It actually boots. Wow. I think I have Unisound in here somewhere. There it is. No sound cards detected. Well, what would cause the glitching? That's very strange. I'm going to plug this directly into the motherboard, not into this riser card. Because maybe, just maybe, that's introducing extra noise or something. It's quite possible. Look at that. No glitching. Yeah, these riser cards, you know, they're designed for motherboards that have one slot and not a whole bunch of slots with cards and then a bunch more cards. So I completely understand why it's not working. Doesn't mean the card's going to work. Yeah, I think Jared told me that that's what his card was doing. It just wasn't being detected. Okay, well, I'm quite sure the Unisound does support this card. And I think that glitching was just not something that was actually a problem. Let's take a closer look at this card real quick. The EEPROMs are still erasing, by the way. It will beep very loudly and annoyingly once those are done. Let's grab something like tweezers just to poke at these surface mount chips a little bit. So let's see if these legs are disconnected or shorted. Ultimately, you should be using a microscope for this, but it's not like I have one. I have one that's just bad. I need to buy a better one. I was at a friend's house and he had one of those stereo ones where you look into it with a stereo eyepiece thing, and it was awesome. That's kind of what I want. I'm just checking to see if any of these move. Like they're not connected properly. But everything looks like it is connected properly. Is that dirt in there or something that's going to cause a short? Okay, there we go. I just use that to blow some air there. Let's check out this PLCC chip. That looks fine. Yeah, it looks good. Just checking anything that's not connected. Yeah, that all looks good. This will be an audio amplifier. There's our EPROMs ready. Just open that thing. Oh, we got a real OPL. Nice. This is actually going to be a good little card if it worked. And all you care about is Sound Blaster compatibility. Sound Blaster Pro, probably. This is weird, though. Why would someone have changed this? Must have gotten broken, maybe. See how it has like a little dent on the top there? I suppose it's possible. I wonder if this is installed in the wrong way. Can I get this to focus? So, it's not focusing. All right, there's pin 1, there's pin 1. They're both installed the correct way around. I'm pretty sure this is a 47K, 472. This one, not that. I'm gonna change this one. Because it's quite possible that these bus transceivers, which I should check that the pins are connected. It's quite possible these are used for the whole sound card as well. Yeah, that's fine. That's fine. Let's move this out of the way. Yeah, those look good. Let's get rid of this and I'll put in a 47K or 4.7K, I mean, into this position there. Actually, let's measure, see if that really is. Maybe I'm just misreading it. I could use my Google Lens to see if that's the case, but it's also trivial just to measure it. So I'll switch this to resistance mode. Pin 1, I'm pretty sure, yep, is right there. So it should be 4.7 to any one of these. Shouldn't it? Hello? Pin 1 is there. Okay. Yeah, 4.6, 4.7. I don't know why that wasn't reading. I was doing something wrong. Don't worry when you see like, yeah, see we're saying 2.2K. I think that's just resistance somewhere else. Let's check this other one. Oh, this is also, oh, there's no need to change this one because it looks fine. I just couldn't read the part numbers that were on it. Well, I wonder why we're getting, what's this? That one's weird. Hello? Nope, there we go, we're good. Okay, everything on the one that's been replaced is correct. Oh, got to measure from the right pin 1, which is right there. Oh boy. Come on. Okay, I'm just going to check these because one of them was 2 point whatever, but I might have been shorting. Yeah, that one, that's weird. I feel that that's a fault. And then that might actually be what's causing this thing not to work. So I suppose, oh, there's another one. So 2 of them are 2.7K. Why don't I pull this off, the one that hasn't been swapped out? Let's just clean up this. Oh, the other day, this is my little drill bit for cleaning this. I dropped it on the floor and lost it. It flew away. So I had to spend an extra 10 bucks to buy a new one. It's not the end of the world, but just kind of annoying. These are the best things at clearing the tip out. Fragile, but worth every penny. All right, so what I want to do is remove this, and I just want to see what the resistance is between those pins with this out of the board. Okay, there it is. That came out pretty easily. First, we'll check the resistance of this. I doubt this is bad. I'm sure this is going to be correct because these never really fail unless they're physically damaged. So everything so far is perfect. Yep. Okay, so everything is perfect on this resistor pack. My assumption is we have a short or something on here somehow. Okay, we can check this from the top side. So it went from here. I think this one was messed up. No, 6 meg. Huh. Well, everything seems fine. 6 meg is completely understandable and normal. Why were we seeing 2K on some of them? And we can see that these just make their way directly to this IC. There. Let's put this on beep mode. Yeah, so that's there. This one's there. That goes there. And let's check that we have any shorts between these pins. We don't. That's very odd. I just noticed this right here. What's going on there? Oh, nothing. I think that's just a little bit of something on there. I don't think that's actually like anything exposed. We can just test that real quick. So it goes from there to there. This one goes to there. Nope. Goes to there. So that looks good. That might have happened when I was desoldering, just because I brushed on those. Yeah, this all, see how there's a little bit there I exposed? It's no big deal. Well, that's curious. Again, I'm pretty sure that the way these are connected up is the same. So see, this pack connects to that, and this pack connected to that. And my assumption is, let's see if this is, which side is this on? Is this going to these? Let's look. Yeah, there it is. All right, so if this driver were bad, for instance, and it's my assumption that this side over here, like one of these pins, let's pick that one right there, probably goes to something on the ISA connector here. There we go. It's you can't see it, but it's like way down at the other end. But yeah, this, so the resistor pack is on the side that faces this. Let's see here. Let's find that again. I assume, there it is. Okay, does it also go to this chip? I just want to know. And this one, by the way, is the 8-bit side because it's down there. This is the 16-bit stuff that goes to that chip. So for instance, the OPL chip is probably on the first 8-bit. Just trying to see if this is even in play for this stuff at all. Nope. Question is, could be the other side. So let's go on to that pin. Right there, make sure it's still, okay, it's connected to the ISA bus. Let's see if this OPL chip is hooked up. It is not. So that means that the OPL chip might be hooked up through one of these other large crystal audio chips. Oh, there it is. Okay. So what this tells us here is that this chip is hooked up to the ISA bus, not going through these bus transceivers. So these resistor packs have nothing to do with anything. This they're simply used for these ports, which makes sense because you have to use a bus driver to go across the long cables. This stuff is all short, and these chips can just talk directly on the ISA bus. Let's see if there's even any other bus transceivers on here. No, there are not any other bus transceivers. Nope. Yeah, so these chips just talk directly on the bus. It's the ISA or these IDE and CD-ROM connections that require these. So that was a bit of a red herring, this thing here. Yeah, something else is wrong. But what? Could this thing just have suffered some kind of damage? Is there a shorted ceramic cap, MLCC cap on here? I don't think any of these caps would cause the card not to be recognized. The whole card's really dusty, by the way. I'm just looking for any kind of gunk, like leaking caps. But at least I don't see anything. Wavetable header, that's kind of nice. Missing crystal, but I guess not needed, because we don't see any signs of rework in that area. Yeah. And everything over here looks fine, all the connections. I suppose I could like bend the board a little bit, then see if it's detected. Let's pop this back in. What happened? Oh, VGA cable fell off. No big deal. Utils. No, it was in the sound directory, Unisound. Okay, I'm going to bend the card. Run that again. Gotta push down on the chips. This is a problem that I'm doing here. Select PMP card number. Try to initialize non-plug-and-play Soundblaster 16. Unisound/CL. List all cards. Faster PNP detection, but less reliable. Oops. Unisound/F. I don't think any of this will do anything. What I should do is look for another one of these cards. I know I have something similar. It's not the same exact one. And then we can see if this is detecting anything, because maybe there's a configuration problem with my computer or something else that's causing this not to work. Let me grab one. All right, here's an ESS card that I just found. This is not Crystal Audio. You know, does Unisound even work with Crystal Audio? I'm sure it does, right? It has to. But let's just see if it can detect this ESS audio drive card. This does have a bunch of jumpers on it, but I don't think those jumpers have anything to do with the IRQ or anything like that. I think it's still a plug-and-play card. I should look at the list of like cards that Unisound does support, just in case it doesn't support this. Media Magic. Okay, Unisound. Aha! It is not working. And I'm pretty sure that card works, this ESS card that's in here. Although, there's no tick mark on it, so it may not. Wow, it's really stuck in that slot. I'm pretty good at putting tick marks when cards are tested. And this one doesn't have a tick mark. It's an ESS 1688F. And it's kind of grimy on the back. How about a plug-and-play, or what is the CT1740? It's a sound blaster of some kind. Unknown if this is a plug-and-play card or not. Let's see if Unisound can handle this card. I want to see at least one card work. So maybe this is just completely a problem with this card not being supported by Unisound or something. It's kind of one of the annoying things about these cards is that it's just like finding the right software. Oh boy, look at me. I'm a mess. Sound, Unisound. Oh. This is an old version of Unisound though. Look at that, December 2019. I swear I had a newer version. It did detect the card though, so that's something. Is Unisound... Yeah, that's old. I thought I had something newer on here, but I guess not. I'm going to get the latest version of Unisound, just in case. So I have a 2025 version of Unisound on here now, much newer. Let's see how this works. I mean, with a card that we know it already worked with. So it's in the sound directory. Oops, I just copied over the old Unisound. There it is, 2025. Wow, they detected it really quick. Non-plug and play. Okay, well, that's probably understandable. This is an old Sound Blaster card. Well, let's get this out of here. Wow, this slot is really stiff. Okay, let's try the ESS card first, which again may not work anyway, so might have another repair to do if this crystal card can't work. Oh, I should turn off my desoldering iron there since we don't need it. No point wasting the heating element by letting it bake for a long time. Unisound. No card detected. Okay, well, I guess this card is not working. This is the ESS audio drive card, and I definitely have used Unisound plenty of times with ESS cards. Oh, I can't get this out. This is ridiculous. I'm just going to put this in a different slot. No, I can't imagine. Okay, well, I'm just going to draw a question mark on the back here to tell us that that card doesn't seem to be working, nor does this crystal audio card. But we'll give it one more try, but I assume it's not going to work. So I think that the first version of Unisound totally supported this card out of the box. And Unisound is just such a useful utility. Okay, nothing. Right. All right, well, we're coming away with two busted sound cards. The ESS card is certainly more interesting, although this one doesn't have an OPL chip on it, but it has the enhanced FM, which sounds awesome when that works. I'm just going to roughly put this back in place if I can. There we go. Put a little tape on it. Deal with that later. I don't think this has any bearing on anything. So I'll just tape over it here just so it's held in. All right, well, this card is a big fat X, as it said there. Very curious. If anyone watching has any thoughts about what to check on these, if there's any things that commonly go wrong with these crystal audio cards, and same with this ESS audio drive, then let me know. I haven't double checked that these jumpers are in the useful settings. I don't know, there's a whole bunch here. I'd have to look up how to set that up. At least there's stuff on here. IO channel ready. This has IDE as well. Sound DMA. Oh, is this actually not a plug and play card? Look at this. So IRQ and DMA, but then CD-ROM enable or disable. IO channel ready. Oh yeah, this is not plug and play. Emulate Sound Blaster. All right. GPI. Closed. Sound Blaster Pro version 3. 220. Low. Okay, so low, both low. So it's set to 220. IRQ, let's check the IRQ. Assume close open. IS, close open. IS1 is closed. Close open. Yeah, okay, IRQ 7, so that's good. There's no conflict. Oh, well, this card might just work. Oh, and there's some MIDI stuff up here, but I don't care about that right now. Let's just see if this is just emulating. This might just work because it doesn't need Unisound. So turn that on. Let me plug the audio cable in. My desk is getting very messy here. I might need to spend a moment to try to clean up a bit. Okay, yeah, I'm going to have to find some cables to plug into that. 3.5mm to RCA because I have, this goes to my speakers. Okay, so Legacy Sound Blaster, by the way, that is, if I let this boot and we look at the auto exec, I have Legacy Sound Blaster. Let's double check it. So go to SB Legacy. All right, so we know that it was IRQ 7. DMA1, I think, was correct. Type 2 is just regular Sound Blaster. I'm going to reboot this and grab a cable. Oops. So first we'll try AdLib compatibility. I'm plugged into the line output on here. Oh, well, that works. Maybe the Crystal Audio card works, but this doesn't have any jumpers on it. So this has to be a plug-and-play card, right? It just has to be. Look at the date codes. I don't really see any date codes on here. Okay, well anyways, let's see if we have Sound Blaster support. Whoops, I thought I pressed F9 for quit. FDoom setup. So we're currently set for Sound Blaster already. Save and launch. Let's see if this works. We're gonna do Doom 1. And I don't have a mouse hooked up, but I think it should work. And we should hear music and audio, theoretically. Well, I don't hear music or sound. And it's very slow because, of course, this is a 36SX. Trying to think what else I have that we could run to test this. Let's see, what's happening? What happened here? Huh, is that a bug or something? It has no menu bar and I can't pick anything. Guess I have to reboot. I have to power cycle? That's odd. But as far as this card goes, this Crystal Audio card, yeah, this has got to be configured through Unisound. This has to be, since obviously it doesn't look like it's configured with the jumpers because there just are no jumpers on it, right? What the heck is going on with this? It just freezes. Weird how it worked once, where I saw it said Sound Blaster, and I think keyboard for controller type, and now it just locks up. If I pull this card out, my assumption is it will work. It must be trying to detect something about the card. Well, I'm assuming there's nothing wrong with this ESS audio drive card. It just is not configured with Unisound. I gotta admit, my knowledge of these like clone cards is quite limited. I know a lot more about Sound Blaster cards. It's pretty much what I used back in the day, and plus I had a Gravis ultrasound. No, this just freezes here too. What is going on with FastDoom? Very strange. I might need to update this or something, I don't know. But what we can do actually, because I think FastDoom is just messed up somehow, I'll put the ESS card back in, and I'm going to try playing a mod file. I have a mod player that should work fine on this older computer. We know the OPL sound is working fine. But yes, my knowledge of these types of cards is very limited. I just don't know what I'm talking about when it comes to them. Not really, at least. Sound Mod Master XT, I think, is the player. Yeah, Mod Master. Freddie wrote this. Freddie also makes the Pico memory card. Yeah, Sound Blaster Pro 2 is what it's detected. So let's see if we have music. Let's pick something here. I don't know which one to pick. I'll pick one of these format songs, Eternity. Yeah, it's working. Cool. Okay, well, there's nothing wrong with this card. It's totally fine. Cool, okay. Well, we'll put back in the Crystal Audio card one more time and we'll just try running it in some legacy mode. I'm sure it's not gonna work. I'm sure we need to have Unisound to drive this, but just in case, I'll plug in the audio. If we hear like a horrible noise, here we go. No, it's just scratchy a little bit. Gotta take this off. This is my little question mark that we gotta remove from the ESS card. That just comes right off very easily. It's kind of grimy, this card. Doesn't need to clean, but I could do that separately. This card works. Awesome. Tick. So there we go. That's a working card. That wasn't in the original docket for working on in this. Let's try Unisound with the Sound Blaster variable set. Nope, didn't do anything. Jukebox, sound jukebox. This is the ad-lib stuff. This is the original ad-lib program. Ad-lib board not found. Nope. And we'll try Mod Master XT. Mod master. Force OPL. Says it DSP34 dot. No, that's not possible. What we saw there was just a no. Yeah, it froze. Totally not working. Yeah, it had like a DSP version that didn't make any sense. DSP versions are usually like 2, 3, 4, that kind of thing, not 34. I think that was just junk data because it doesn't know how to detect this card. Okay, this card is definitely bad. So do I already have an X on here? Yes, there's already an X on here. So that's good. It's bad. So we'll pop this over here. There's just cards everywhere here, everyone. Cards everywhere. Oh, what's left to test is this EGA card. But what I want to do first is that we are going to flash XT IDE large onto this chip. To do that, I'm going to have to do a new configuration, I think. So let me just get my bearings here. I think what's on this card already, that's this 4 gig card, already has the large XT IDE files or the latest version on there. So let's see if that's the case. So because we'll have to do that configuration stuff that we did a moment ago on the other one, IDE, XT IDE CFG. Yeah, R631. That's the same version that we had on my little card here. So let's load this AT large. Cool. Now we're going to do configure. Primary card. Actually, we'll change this to one controller. Primary controller. Everything looks good here. Oh, the IRQ was wrong. I think it was set for 15 on the other one. Ah, so that was my bad. I'm pretty sure it was set to 15. So that's probably why it was not working correctly. Everything here is correct. Disable detection. Oh yeah, you can disable that drive if you want to boot faster. I should probably do that because I don't really need the second drive to work. Just need the first drive, this one. Okay, boot settings. You can change the color theme now. I think I like green. I don't know. Oh, wow, that's terrible. Argon blue. Moon surface. Toxic waste. We'll use that one. Sure, it's really bright. It changes like the F key stuff when XT IDE boots. Timeout, 100. Make that shorter. In fact, I'm making it 50. Remove other hard drives. Okay, this looks good. Use UMB for variables. I'm just going to say no, because I don't know if that's going to break things. And we'll save this back to original file. There we go. Turn this off, take this out. Program, but I'm currently, this is a TMS 27128. Whoops, that popped up. So 27C128, and it's a Texas Instrument one. So TMS 27C128. We're going to load. We'll have to go find the XT IDE file that we saved. So it should be under here, XT IDE, AT large. There it is, AT large, 12K. We're going to fill the buffer, by the way, with zeros. So basically at the top of the 12K that this takes up, there will be that checksum byte, if I find it. I think it's at 2FFF. There it was, right there, K. And then the rest of this is all zeros still, just so it's easier for us to see what exactly gets mapped. And is this correct? Check ID. This is a TMS, but the ID doesn't work. It worked. Cool. Okay, this is the original chip, the one that was on this card originally. Try to untangle this insane mess of wires I have here on the bench. We'll program this a couple times, just like I always like to do. And hopefully this should do the trick. And I think the problem last time was simply I had the IRQ wrong. I had set for 14 when, or had set for 15 in XT IDE when it should have been 14. The primary controller is always 14. All right, 3 times is good enough. Let's make sure we put this on the correct way. Don't bend any pins, Adrian. Don't bend any pins. Okay, there we go. So notch is towards this side as it is on the rest of the, pop that in there. Got to find my card, pop this in. This is the 4 gig one. Okay, let's turn this on. I'm gonna go fix that flashing thing. Sorry, caching. Shadowing, that's what I meant. There we go. All right, are you gonna work? Come on. Yes, yes. All right, maybe? Yes, it's freaking working. Awesome. This is great. Let's run debug first of all. Let's look at what we see here. So there it is. Oh, weird. Oh, is that D800? No. I'm going to turn off EM386. Yeah, I don't know what's going on. Oh, D800. Oh, gee. All right, whoops. I left the little card in again. Did that again. Let's try this again. I did it twice. Come on. Oh, no, it didn't work. Come on, why? Oh. Oh, hold on, everyone. Is the jumper set to disable? Yes. When it's on, it's not disabled. When it's off, it's disabled. This video is just super random, but this is how it goes with this retro hardware. This is a whole lot of like fiddle-faddle. Okay, it only detects the one that's correct. Hold down shift. Ugh, I was too slow. Okay, well, it's working anyways. Utils, check it, HD speed. $1996. Interesting how that's a little bit slower, but I'm going to reboot again without EMM386. I'm going to hold down shift, which is what I was doing before. It only detects the one drive, which is correct. There we go. Utils, check it, HD speed. Is it any faster or is it slower? Oh yeah, 2381 kilobytes per second. Excellent. So we're good. We're up and running on this card. This is a great card because I have XT IDE on here and I don't need to have that little extra card now. I am loving this. Totally awesome. So what I'm going to do is I'm going to write some stuff on the card just for my knowledge because I haven't really done the work to experiment with all these jumpers to kind of figure out how to say turn off the floppy controller. I would like to be able to do that just so if I don't want it to be there, I'd like to have a jumper, and I just bent the heck out of those pins. I'll be switching them out anyways for the right angle ones. So first off, J11, let's see, J11 off equals disable. Okay, so J11 off is disable. What I do need to do is I'm going to write BIOS at is C800. I just like to know where the BIOS is, you know, without having to guess. That way, if I'm plugging this card in and I don't want to conflict with something else, I wrote it on there. I'm sure there's a way for us to switch it. I don't know what that is. And I'm just going to stick a little thing on here because if I don't stick something over that window, people are going to say, you're going to lose your contents. Oh no. But do I care? Because I could just put new copy of XT IDE on there, but we'll just do XT IDE. There we go. That was just a little offcut from my label printer. Cool. Well, there we go. This freaking works. It just needs to have the right angle connector installed. I'm gonna bent the crap out of it. And then what I'll do is just like my other card that's on there. Oh, wow. I had this in there at the same time as this one. Whoops. You're not really supposed to do that, but I did it. If it was trying to address the floppy controller, we would have had a bus conflict. And I guess the fact that this card wasn't creating a bus conflict. Okay, well anyways, it was working even with them both in there, and it really shouldn't. Anyhow, I'm gonna do the same thing I did on this card, which means modify it with the right angle. Also, I'll have to run power directly to here, just so it powers up the card all the way. Some of these adapters, you can just power through one of the pins. I think I had to repair this. I think there was a, oh, no. I caused that damage. See this here? When I removed this, I actually ripped a trace. So that was me. But anyhow, I'm going to modify this in the same way as this card with the right angle, the LEDs, and then I have built-in XT IDE, which is awesome. I love that. So that was a win for me. And I will upload a copy of the other BIOS that was on there, the original one, somewhere like GitHub or archive.org, I mean, just so you can have access to that if you are looking to decode what that does exactly or want to use it on your card just to be original or whatever. It'll be available. It'll be preserved. So we have this EGA card. Let's see if this works. I need to find a cable to plug this into my RGB to HDMI, which is this cable right here. This will do the trick. There's extreme likelihood that this just works. These are very reliable, these cards. All right, so select profile, IBM compatible, EGA. Oops, that was not the right one. Let's get this to the correct one. The IBM EGA is the best. And let's see what happens. Here we go. Turn this on. Right, we're not seeing anything because I have a feeling this is probably set to monochrome mode. So let's switch this to MDA. What happens if you switch to MDA, the dip switches that are on here, then what, oh boy, look at me. It's not outputting color through the same pins. Yeah, there we go. So that works. We just need to plug my IDE card back in so we can boot. So as I was trying to say, when you're set to MDA mode, the video signal is only coming through the pin that MDA uses, which is a different pin than what EGA uses. So that's why we just saw nothing. But it's still running as an EGA card. Ignore the fact that it's shifted off to the side. Sorry about the beeping. That was just me trying to skip the... I pressed caps lock, not shift. With check it, I'm sure we have EGA, yes, but the video mode is set to MDA. Yep, and that's because that's how those switches are set, I think. It says 0010 for EGA switches, but there are 5 on here, and it doesn't support showing 5. Now, I've been working on these dip switch helpers to help me with switches, and this is one I made for the EGA card. Now, I was going to make it where I could add like this Paradise card to the little database or whatever. I haven't gotten around to that. So right now we just have the actual IBM card. So I think this matches, because remember it said for the card that's in here, it's like up, up, down, up, 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 down, up, and that's MDA. So I'm going to set it for 350 line. So up, down, down, up. This is all dirty and dusty, but let's see if that matches. I don't know about the 5th extra switch, what that does. So there we go. I just configured it to match this. Monitor type, obviously, that's for the IBM card. And what this little utility lets you do is, yeah, you just can either twiddle these or set this setting you want. And I have similar things online, so you can access it for the IBM 5150 and 5160. So you can pick what you want. So for instance, if you're working with an XT and you want to have it in CGA 40x25 and no math coprocessor and 2 floppy drives, then that's how the switches are set. Or you can configure the switches based on what you see on the motherboard, and it will tell you how it's configured. So I find it very useful because I'm tired of looking stuff up all the time. How much RAM you have, 640K. So for instance, math coprocessor not installed, 2 floppy drives, VGA, that's how you would switch the settings to. And for the 5150, same thing, like that. There's memory stuff, it's, you know, there's 2 blocks of switches. And I made one for the XT IDE as well, because I'm tired on the actual 8-bit card of having to look up all the switch settings and how this all works. So it's similar, same thing. So you can pick where you want the ROM to set up. So D800, ROM enabled or not, write enabled for flashing, the size of your EEPROM, also your base IO. So say you want to have it at 320, then that's how the jumpers are configured. And you can also move these if you want to look at how a card is configured, and it tells you the summary and stuff like that. So yeah, I made these little helpers. They're available on GitHub, so you can like host or look at them on your phone. Basically, they're on GitHub, and then there's like a preview feature which lets you just run the HTML file kind of like it's a web server. So I hadn't uploaded this EGA one, so I will upload this as well. We'll see if this actually works for 350 line with this card. Let's reboot the computer. So I already made the change while the system was powered on, so let's power this off. We will need to switch the RGB to HDMI over to the correct mode though. So we'll go to IBM and we'll pick EGA, return, and let's turn this on. Yep, there we go. It freaking works. Keyboard error. I tried to go to the BIOS settings, but whatever, it's booting. So this totally freaking works. This card just works. I'm not surprised. These cards are incredibly reliable. Oh, that doesn't work because I'm loading Nancy or whatever, and that version of Nancy I think really doesn't work with any but VGA cards. And Nancy speeds up the text mode. But let's just do a quick test here. We'll use check it. And we can check the various video modes. Look at that. It looks so nice. So test video, all tests. 256K, passed. Text modes, passed. Yeah, it's kind of slow. I mean, whatever. This is going to work. I'm sure this is going to work fine. Come on. It's slow. EGA was capable compared to CGA, but man, was it slow. Yeah, it's just going to go through, test all the modes, whatever. Super slow. CGA mode. I want to get to the graphics modes. There we go, 16 colors, 350 lines. I don't know what that fifth dip switch does, but the first four seem to work exactly like the IBM EGA card, so that's cool. There is 350 line mode right there, looking good. This is CGA mode. There it is, 16 colors. Something was not possible on a regular CGA card. There we go. Cool. Well, this card totally works. Let's just see how slow it is, because it's going to be slow. Compared to the VGA card, yeah, EGA is very slow. 500 characters per second. You know what? That's actually similar to this card. Anyways, cool. That card works. So this gets the tick mark. I should do it with this, the paint pen. Tick. Okay, there we have it. That's the end of this video. I have low blood sugar, so I really do need to run, but this EGA card totally works perfectly. This hard drive controller works perfectly, and now with XT IDE, it is so much better. I determined that the 008 state jumper on this card, the video card, does not work, and the VGA card I thought didn't work, does work perfectly. And lastly, we tested a couple sound cards. This ESS audio drive card, that works. It doesn't seem to support plug and play, but it totally does work. And this card definitely does not work. So I'm looking for any help. If you have any familiarity with this card, you know what things go wrong with it, maybe you could suggest what I did wrong. Yeah, nothing looks out of the ordinary on this, so something's the matter here. This card, the Sound Blaster card, I didn't really test the audio, but this does seem to work. I don't have a tick mark on here, so I'll do some further testing at some point in the future. So that's it for this video. If you like this kind of just random testing and stuff, let me know. Thumbs up would be appreciated. Comment down below if you have any thoughts on what you've seen in this video. And subscribe if you haven't already. Huge thanks to my supporters, you know, the usual YouTube stuff. And that's going to be that. So stay healthy, stay safe, and have a wonderful Thanksgiving if you're here in the US. Otherwise, I'll see you next time on one of the channels. Okay, bye. That's a weird outro, but yeah, goodbye-bye.